We're dealing with sequences. We've been looking at the arithmetic sequences, and the number that we are like adding or potentially subtracting is called the common difference. So what's written in orange here is what the book gives, like the form for how to find the next number in the sequence, but this requires that we know the prior number. So this one that's in blue is what they gave us in the videos the other day as a different way to find it that I think is probably actually easier, because you can know one of the terms and then be able to find the other ones based on that, whether it be the first term or you want to use the third term or whatever, and then you can do n minus k and then times the common difference and find it that way. And then for the geometric ones where we're multiplying by something, we have the common ratio, and again we had this form that's written in pink that is what's given in your book, but the one in blue is what they used, and I do think that that's easier. And so you just have to know one of the terms, and then you do r to the n minus k to find whatever number term you're looking for. So that being said, the first one say to find the first 6 terms, and it says and the 100th term of the sequence. We're just plugging in numbers, so that's why. So number 2, v sub n is equal to 4 over n plus 2. And so all we're doing is we're finding the numbers that go in here, or the sequence, the first 6 numbers, and then out to the 100th number. And so all we're doing on these ones is literally just plugging it in. So this would just be like 4 over 1 plus 2, which would be 4 over 3, and then 4 over 2 plus 2, which is 4 over 4, or 1. And this is going to be and so on and so forth. I'm just going to do it without writing them all out. But if we plug in 3, it would be 4 over 5. If I plug in 4, it'd be 4 over 6, which would reduce to 2/3. If I plug in 5, it would be 4 over 7. If I plug in 6, it'd be 4 over 8, which would be 1/2. So that's the first 6 terms. And then they say the 100th term, which would be 4 over 100 plus 2. So that would be 4 over 102, which would reduce to 2 over 51. And so that's all they're looking for on those ones. It's just basically writing the terms. So nothing too crazy here on that one. I don't know. They didn't really talk about that in the AP stuff, so we'll probably skip that. I'm going to skip the stuff that's like if it's converging or diverging, because I don't think that they talked about that in regards to AP, but that's just basically like if it's like going to something specific, or if it's like just like going away like out to infinity. But I'm going to get into what's actually going to be on there, and that's the sequences. These ones say the sequences are arithmetic, so we're going to be adding or subtracting, find, and then there's 4 things we're going to be finding. And so the first one is the common difference, then the 10th term, a recursive rule for the nth term, and then an explicit rule for the nth term. And so we'll talk about what the difference in those things are that they're asking you for. But 22, -4, 1, 6, 11, ... So what am I doing to get from -4 to 1, 1 to 6, 6 to 11? How am I getting there? Like, what's the common difference between these things?
Adding 5.
Yep, adding 5. And so when it asks for the common difference, we would just say plus 5. So this is the first 4 terms, but they want the 10th term. And so we could keep going here. So that would be 16, 21, 26, 31, 36. What number is that? 9. 41. So that means that then my 10th term would be 41. Which it's fine to do it out by hand. Not hard to add 5, right? But having a rule to be able to do it is much easier. And so what we can do is, this one is the recursive rule for the nth term. Which is just, we say basically, okay, what is the first term that we're dealing with? So a sub 1 is going to be -4. So then, according to the way that, again, they wrote it out in the notes, because that's what finding the recursive thing would be, a sub n is equal to a sub n minus 1, so it's whatever the previous term is, plus 5 is what that's saying. So if I'm looking for a sub 2, then we would have a sub 1 plus 5, and that gives me my second term, which would be 1. So that's the way that would work, and we would need to specify here for n greater than or equal to 2, because you can't use this if you don't know at least the first term. But the explicit rule, which is going to be the one that I would say we would tend to use, and this is going to be more the one that they gave us in the video. The explicit rule is going to be that a sub n is equal to whatever the first number is, plus the common difference times n minus 1. So whatever number you're looking at, minus 1 would be that. And in this case, like 1 is k. But remember, we can use whatever. If I wanted to use 6, that's the third term, then I could do 6 plus 5 times n minus 3. Right, whatever term that is what I would have to use to find that. I would just use the first one. It's easier. But anyways. But that's how we would write that one, which is, again, more this form here, which is easier, in my opinion, to use. Any questions on that one? Let's see. 24. So same thing with this one. I'm not going to write out like exactly what everything is. I'm just going to write A, B, C, and D this time. So 24 is -7, 4, 15, 26. ... So what is the common difference? How am I getting from -7 to 4, 4 to 15, so on and so forth? Add 11, yep. Now, part B, I don't feel like, no, I am capable of adding 11 to get out to the 10th term. I really don't feel like adding 11 6 more times to get that. So I'm going to skip B, and we're going to come back to it using part D in just a second. Okay, so C is the recursive rule. So that means I need to say what a sub 1 is. So a sub 1 is equal to -7. So then we've got a sub n is equal to a sub n minus 1 plus 11 for n greater than or equal to 2. Then D is the explicit rule. So I'm going to have a sub n equals the initial number, so -7, plus the common difference 11 times n minus 1. So now if I want to find the 10th term, I think that's what it asks for, yeah. The 10th term for part B, I'm going to use this rule and find that. So I would do a sub 10 is equal to negative 7 plus 11 times 10 minus 1. So 11 times, this would be 9 is 99, minus 7 is 92. So that means that, going back up here, part B, the 10th term would be 92. So being able to find this rule, specifically the rule from part D, is going to be really critical that you understand how to do that, to write that rule for the AP exam. Because that's going to be, they're not just going to say, what's the 5th term? Like, they're going to give you something where you need to be able to plug it in and figure out what the term is that they're looking for in the sequence. So, any questions about those ones? Those are the only 2 of those in here, so that's why I'm asking. All right, then going down to geometric sequences, they tell us the sequences are geometric. And the other thing to remember is on the AP exam, they're not going to tell you which type of sequences you're going to need to be able to recognize. But I mean, it should be pretty easy. It's going to be clear that they're either adding or subtracting or they're multiplying, right? If they're adding or subtracting, it's the kind we just did. If they're multiplying, it's geometric, which we're about to do. So number 26, we have 3, 6, 12, 24, ... Keep forgetting that part. So A, they want to know the common ratio. I did that the other day. I was out somewhere and it just like came out of nowhere. And my dad was like, "Are you good?" He's like, "Are you okay?" I was like, "Yep, I'm good." So what do I need to multiply by? Because we know this is geometric, to get from 3 to 6, 6 to 12, 12 to 24.
Times 2.
Yep, multiply by 2. So the common ratio is 2. Now, instead of wanting to know the 8 or the 10th term this time, they just want to know the 8th term. So I can do this by just continually multiplying by 2 if I want to. So I'll do that for this one, and then the next one we'll use the formula to find it. But they want the 8th term. So if I continued on, multiplying by 2, that would be 48. By 2 is 96. Oh, goodness. What is that, 192? Somebody's going to have to multiply that one for me. Thank you. I was like, I don't feel like doing that in my head. So 384 would be the 8th term. Part C, they want their recursive rule. So that's going to be very similar to what we did in the last one, where we're writing it out more like the book did, and then the explicit rule will be more like the AP video way. So recursive rule, a sub 1 is equal to 3. So then a sub n is equal to 2. So it's the common ratio times a sub n minus 1 for n greater than or equal to 2, because as we've said, you have to have the first term to be able to do that. Then D, a sub n, or hold on, let me rephrase. This is the explicit rule. We would have a sub n is equal to whatever the first term is, so 3, times the common ratio, so that would be 2, raised to the n minus 1, and so that's how we can find any term. Again, with these ones, you have to know the previous term in order to be able to do that. That's why it's called the recursive rule. So this is a sub 1 times the common ratio raised to, not ratio raised to the n minus 1. Just if you want to see where we got that from. Now let's look at 28. We've got -2, +2, -2, +2, ... So what is my common ratio on this one? Yep, -1. They're multiplying by -1 every time. B, we need the 8th term. What's the 8th term going to be? Yep, the 8th term is going to be positive because every even term is positive here. So it's going to be a +2. So I may go back and do the math of using this one because this one's not really a great one to use it for. So my recursive rule, a sub 1 is equal to -2. So then a sub n is equal to common ratio, -1 times a sub n minus 1 for n greater than or equal to 2. The other way you could write this is just -a sub n minus 1. Like, that's also fine. Thank you. Yeah. So either way is fine. If you want to, like, for lack of a better term, explicitly write the common ratio of -1, you can. But if you try to negative, obviously it's understood that there's a 1 there. So either of those is fine. What would my explicit rule be? A sub n equals what?
-2 times -1 n to the -1.
Yeah, raised to the n minus 1. I think that's what you meant. Now, I'm going to show you, there's one other way this could be written. Actually, no, I'm not. We're going to leave it at that because it's going to confuse you if I write it the other way. We're going to leave it that way. But I am going to go back, since obviously on this one, it was really obvious. It was -2, +2, -2, +2. I'm not going to go use this form for this. But I'm going to go back up here and just find the 8th term using the rule so that we see it. So if I did this, I would have a sub n, or a sub 8, is equal to 3 times 2 to the 8 minus 1. And so then I would do 3 times 2 to the 7th. I don't even know what 2 to the 7th is. Let's find out. Nope, not in stats mode. Thank you. 2 to the 7th times 3 is 384. And so that's another way that you could obviously go about finding that. So anyways, that's really all for this section. The only thing that I would say to also keep in mind that I don't really think our book has, let me look and see if I'm missing it anywhere. Something like 39, I'm going to have you just try that in your homework, where it's like a word problem type thing. Just see if you can figure it out more for fun. But it's not, obviously it would be more of a multiple choice question, but it's obviously not in here. It's just a finding, solving it. But 3, which will just be like number 2, and then 21, 23, 25, 27, and then 39, just for kind of an example of a word problem. But basically, they show you basically it's like the setup of an arena, and they want you to figure out how many seats are in the section if the first row has 7 and every row after that has 2 more in it. So they want you to basically, once you find out how many are in each row, add them all up to give the total number of seats. So it's just like a little bit of a different type of word problem. But something like that could easily be a multiple choice type question in those sections. So I don't really see another like good one that would be more like that. 45 is another multiple choice option. 45 that is something more like you could see. So we'll call it a day at that.